So we have done linear, we've done it with Sir. So hopefully you're going to be able to recognize that an equation in the form y equals to mx plus c is a linear equation. So when you choose some x coordinates, some y coordinates, and you plug them into your equation, you're going to get some y coordinates, you're going to plot them, you're going to get a straight line. So just as a recap, hopefully remember the number in front of the x is the gradient. So the higher the number, the higher the gradient, the steeper the line. I prefer to remember it as the difference in y over the difference in x. You hopefully also remember that the intercept of the line is this, whatever comes after the term in x. So in my case, I know this line is going to have a gradient of 3, it's going to be reasonably steep, but it's not going to go through the origin, it's going to go through 0, 1 on the y-axis. Last thing you hopefully remember is that when the gradient is positive, as it is for A, B and C here, the line looks like it's going up, and when the gradient is negative, the line looks like it's going down. So those are our linear graphs, which was just a quick recap. We haven't done quadratic graphs, which are the next two. So they are called quadratic graphs, and they are graphs of quadratic equations, believe it or not. So basically, whenever you have an equation y equals to x squared something something something, the x squared tells you that equation is a quadratic. So when you plot it, you are going to get smiley faces if the term in x squared is positive, and you're going to get sad faces if the term in x squared is negative. So the original one is this one, y equals to x squared, which is here. And then whatever happens to it is just a transformation of the original. So for example, you see for this one, the original just moved one space up because of that plus 1 there. In this one, you see it's still the original because of the x squared, but only it moved 2 spaces down because of the minus 2. And the same idea basically applies to negatives. Okay. Next, we've got cubic graphs. So they are called cubic. And why does that always happen? And they're called cubic because they are graphs of equations with terms in x cubed in them. So the highest power of the x is x cubed. So the original, let's call it, the main one that you guys have to remember, looks like this. And the negative one is the other way around, basically. Yeah, so it's just a reflection in the y-axis, if you want to call it that. The way I like to remember it is, if you look at this one, it kind of looks like it's going up, like you have to climb it, and this one, because it's a negative, it's going down. So these are the originals, and now, same as with the cubics, as soon as you start doing stuff to the terms in x cubed or x squared, or terms in x, or the last number in the equation, which is the intercept, the graph starts to change. But the idea is exactly the same. If you see, this one is kind of like a squished version of the first one, and this one is a negative, so it's kind of same, like a squished version of the first one. I'm not going to go into any more detail with them for now. All you guys have to do is just remember the shape, remember the way they look. The next ones we are going to do are called reciprocal. and they are always in the form y equals to some number over x. So the one that's on the screen now is y equals to 1 over x. If the number changes, for example, if you have 2 over x, the graph maintains the same shape, but it moves slightly a bit straighter than mine, more smoother. But it basically, all it does is it moves away from this origin. But the idea, the look of it is exactly the same. So this really ugly one I drew here would be y equals to 2 over x, for example. Y. We're back. Okay, cool. So let me just quickly show you what would happen if the bit that's after the equal sign is a negative. So for example, if I had y equals to minus 1 over x. Okay, so if I had y equals to minus 1 over x, the graph would simply just be here, but it would look exactly the same. Maybe I should change colors. Yes, so that is the negative one. Let me see if I can get a bit of purple up in here. So yeah, that would be it. That would be the negative one. Okay, so remember, these two are positives and the other two are negatives. Right, the last one I wanted to talk to you guys about is exponential functions, exponential graphs, whatever you guys want to call them. Okay, fine, let's do on purple. This is basically, it's explaining to you what the graph represents. It shows just really rapid increase, which you can see on the y-axis. And it's of the form, we just talked about functions last time. So f of x equals to a number to the power of x. You can easily say that as y equals to a number to the power of x. So these two are exactly the same thing. An important thing to notice about these graphs is that no matter what the a is, so what the number is, this intersection here, so they intersect the y-axis at the point 0, 1. So for example, if the one here would be y equals to, I don't know, 2 to the power of x, it would go through at through the y-axis at 0, 1. Okay, so let's have a look at an exam question, which is the next thing on your handout. Let's see it. So here are 3 graphs. There they are, A, B, and C. Here are 4 equations of graphs. We want to match each to the correct equation. If you want me to quote MathSwatch, if you want to, you can pause me now and try to match them up and then play and check it out. I'm going to go through them. If not, just make an idea of what you think the answer is in your head and keep watching. So the way I prefer to work on these questions is I'm basically deciding what each graph is and then search for the equation that matches the graph. So I know that the first one is a quadratic. Okay, because it looks like a smiley face. It's not quite the original, because remember the original is something like this. So obviously going through the origin and much smoother and nicer than mine. But there's something happened to it that made it move up the y-axis. But I definitely know it's going to start as y equals to x squared something something something. So if I have a look through my equations, the second one is y equals to x squared plus 4. There's nothing else that starts x squared plus 4, so that means I know a is equal to, so a is that quadratic, so y is equal to x squared plus 4. The next one is, we said, the original form of a cubic. So if you plot y, that's a cubic. So if you plot y equals to x cubed, you're going to get this graph. So all I have to do is just look for y equals to x cubed. Here it is. And the last one, we said it's an exponential. They always look like this. So here it is. It's basically the one we've been discussing about on the previous page. So y equals to 2 to the power of x. And that was it. Okay, so you guys, if you're still slightly unclear, you'd like a bit more details, check your show my homework. I'm going to list the must watch clips that you should be watching there. I'm going to try to do the last clip for this test, which is what is it? Oh yes, circle theorems and proof. All right, so see you for the next one. Bye.